Hi guys, hi, how are y'all? Welcome to another episode. So today teacher is going to guide y'all on area of sector of a circle. So we are still using your form 5 textbook. Okay, for this time it will be page 13. Okay, page 13, and we will look at how to do area of sector of a circle, and we will be practicing self exercise 1.5. So I'm going to guide you on that step by step. All right, so let's get started. Don't forget to subscribe, like this video, and of course share this with your friends so that you guys can also study together. Okay, so teacher hope that you guys are ready with your textbook, notebook, pen. You can have color pens. Okay, be ready with calculator, and of course if you're a coffee person, you have your coffee or your tea. All right, so let's get started. Before this we learn arc length, and the arc length formula, if you still remember, S equals to R theta. R is radius, theta is the angle. Now area of sector, okay, this one is going to be, if you want to find area of sector, you need to remember 1 over 2 R square theta. Okay, so this will be area of a sector. So sector is just one part, okay, this part here. Okay, so what is R? R is radius. Okay, what is theta? Theta is the angle, and make sure your theta is always in radian. All right, so we are going to use the formula, we're going to apply it, and now teacher is going to do self exercise on page 14. So you can turn to page 14, and I'm going to do self exercise 1.5. so be ready to do it together. So I'm going to write the question first. Alright, so I hope you're ready with first part of the question. Okay, for each of the following sectors, find the area. Okay, so let's straight apply the formula. Okay, so this is the formula to find area. 1 over 2 radius 2 times square it, okay, and then theta. Okay, so let's do for the first one. So to find the area of this, 1 over 2 times with the radius is 6, so 6 square. Theta, the theta is in radian, so I don't have to change anything. Alright, so let's just key in. So we will get 1 over 2 times 6 square times 1.1. We get 19.8 centimeter square. So make sure your unit is correct, okay, because this is area right now. Okay, let's find for B, area of this sector. So we apply 1 over 2 times the radius square, 2.15. So I think you have already found all these, right? Because this one is quite easy, okay? Times 2.15. So we get 107.5 centimeters square. So 107.5 centimeter square. Okay, now let's look at the third one. What is the difference here between this question and this question? The theta is outside. Okay, theta is outside, so we're not really interested with the outside one. We really actually want the inside theta, isn't it? So how to find the inside theta? Still remember or not from arc length where teacher taught you? Okay, what you must do is take the outside radian minus take 360 minus this outside radian so that you get the inside. All right, so we take this 5 over 3 because we want to find the theta first. Okay, so we take 5 over 3 pi minus, oh sorry, we have to take not 5 over 3 pi. 5 over 3 pi is the outside one, right? We want to find the in, so we have to take the whole thing, meaning that what is an angle of the entire circle? It's usually 360 degree. So 360 degree is 2 pi. Okay, remember this, because 180 is pi, so 360 is 2 pi. So we take 2 pi minus 5 over 3 pi. So of course you can actually key in or substitute the value of pi as 3.142, okay, because that's what we are asked to use. 3.142 minus 5 over 3, 3.142. all right, let's find what is theta first. So 2 minus 5 over 3, then 3 times 3.142, so you will get 1.047 radian. Okay, so this is our radian. Now let's find the area. Okay, now let's find the area. So the area will be 1 over 2 times with the radius. The radius is 5 square times 1.047. So 1 over 2 times 5 square times 1.047. So we get 13.09. So we take up to 4 significant figures. 13.09 centimeter square. Done. Okay. So now let's look at the last one for D. Oh, this one also is quite easy, but the only thing you have to change is the 135. Okay. So if you want to change to radian, so we change the theta first. Okay. The theta is 135 degree, but I want to change it to radian. So we times by pi over 180. Okay, so you can change the pi to 3.142. So 135 times 3.142 over 180. So we get the theta is 2.357 radian. Okay, I'm taking 4 significant figures. Now let's find the area. 1 over 2 r square, theta is 2.357. Okay, so let's times 1 over 2, 1 over 2 times 20 square times 2.357. 471.4. Okay, 471.4 centimeters square. So I hope you guys are by now like already alert. If your theta is in degree, you must change it to radian. Okay, so now let's do question 2. Alright, let's do question 2. Okay, now let's look at question 2. A sector of a circle has radius of 5 cm and a perimeter of 16 perimeter. Find the area of the sector. Okay, so let's actually draw a sector first. Okay, let's draw a sector. Okay, this is our sector, and radius is 5 cm. So 5 cm. So I'm just going to label this as O. This is A. This is B. Okay, so the radius is 5. Perimeter is 16. Theta not given. Okay, theta is not given, so we have to use the information that we have here, perimeter. So perimeter means what? We have to plus all the sides. So that means 5 plus 5 plus with the arc of AB, we should get 16 cm. So to find the arc of AB, that means 5 plus 5 is 10. So 16 minus 10, 6 cm. Okay, so this part here is 6 cm. Okay, the arc is 6 cm. So now can we find the area or not? Okay, so let's find the area, but we still don't have the theta. Okay, because if you want to substitute inside the area, you need radius, you need theta, but we don't have theta, isn't it? So let's find theta first. Which formula can we use to find theta? I think by now you guys should already know how to relate to the previous subtopic that we learned, which is arc length. Okay, because here we have the arc length, so we can use the formula S equals to r theta, because S, the arc, we have the value, radius we have, so you got two values here, you just need to find the theta. Okay, so let's do that. So 6 equals to 5 times theta. So theta is going to be 6 divided by 5. So let's get how much is it. So 1.2 radian. So this is in radian already, yeah? Okay, not 1.2 degrees, already in radian. 6 divided 5. So theta done. Now let's find area. Okay, so 1 over 2 radius square and times with theta. So 1 over 2 times radius square times 1.2, we get 15 centimeters square, and done. Okay, I hope you guys tried this before I actually showed you the method. Okay, because these are the types of questions that you should start getting yourself able to answer within 2 minutes. Okay, so since I'm explaining, of course it's going to take longer time, but if you're doing this, you should know how to relate to the previous subtopics. Okay, now let's do question 3. Okay, you can get started first. Okay guys, so teacher is ready with question 3 now. So let's do it together, or if you have done, that's really good. So let's check your answer step by step together. Okay, the diagram shows a major sector. Okay, it's a very big major sector. Center O, radius R, area is 195. Calculate the value of R. Okay, so we want to calculate radius. Okay, so if you want to calculate radius, the information that is given is area. So automatically you must use the 1/2 r squared theta. Okay, because area is given. So I think we can straight away do for A. Okay, straight away immediately apply the formula. So the area is 195. Okay, so 195 equals to 1/2 r square. Theta is 3.9. So in this case now here, okay, we're just going to take 1/2 and times with 3.9. Times with 3.9, we get 1.95. So 195 equals to 1.95 r square. So how to find r square? Bring the 1.95 over to the left hand side. So we write 1.95. So we'll get 100. So what is r? So square root of 100. Of course plus minus 10, but we will always take the positive. Okay. So the radius is 10 centimeter. Okay. So this is supposed to be your first question. Step-by-step work. So now let's do for B. Find the major arc length. Okay, still remember what formula we're supposed to use, because we are supposed to find arc length. So arc length always relate back to S equals to r theta. So we want to find this part, the major arc. Okay, here I want to find this. So S equals to radius is 10, theta is 3.9. So 10 times 3.9 is 39 centimeter. So done. So this question is quite easy. Okay, next one, C. Find the perimeter of the major sector. So obviously perimeter is take this whole thing plus with the EO, length of EO plus with length of OF. Okay, so the length, okay, let's see, length of EO plus, I'm just going to write in detail for you, okay, plus length of OF plus arc length of EF. So you understand from where teacher is taking the measurement from. So EO is 10 cm, OF is 10 cm, then here is length arc is 39 cm. Okay, so here 20 plus 39, 59 centimeter. So the perimeter is 59. Okay, so now let's continue to the last question, question 4. I hope you guys are ready. Or you guys have done, then really good. Let's check your step-by-step answer. Okay, so now teacher is ready with question 4. Let's get started with the step-by-step. Okay, the diagram shows a sector VOW. You have center O. Radius is 10. Theta is not given. Okay, they ask us to find the value of theta. So the area of sector, the area is given. Area, immediately you write down 1/2 r squared theta. Okay, straight away. If can, this is something that you should memorize already. Okay, so the area is given. Calculate the value of theta. Okay, so let's apply. So area is 60 centimeter square. So we're going to apply that. 60 equals to 1/2 r is 10 square theta. So the theta is the one we're going to find, right? So 1/2 times 100 will be 50. So 60 equals to 50 theta. So our theta in radian will be definitely 1.2, I think. So 60 divided by 50, 1.2 radian. Okay, so the first part done, because we straight away can apply the formula. Okay, let's find for B. Arc length of VW, this part. Okay, so usually arc length, what's the formula we use? S equals to r theta. Alright, so S is the one we need to find, r we have, theta we have. Okay, this is also simple. Just plug in the values. So 10 times 1.2, 12 centimeters. Done. Okay, and the last one, C, perimeter of the sector, VOW plus everything up. So we have to take the length of, okay, OV plus the length of, okay, OW plus the arc length. Okay, the reason why teacher is writing all this for you is so that like you are familiar, because now you're starting. Okay, so it's good to always write down so that it's until you really understand, okay, this is length, this is arc length, so you need to differentiate. So 10 plus 10 plus arc length is 12, so we will get here 20 plus 12 is 32 centimeters. So that is the perimeter. So I hope you guys did this together with teacher. Okay, so make sure you do it step by step. I've also mentioned it previously in my video. Make sure you are organized. Okay, make sure when you write down something organized, don't write area here and then area here, then suddenly, you know, do not mess it up. Just make sure that it's organized. Okay, so now after this, teacher is going to go into area of segment of a circle. So before I go to the next part, just be ready with page, okay, 16. Okay, we're going to do page 16 self exercise. But before that, I'm going to explain an example from the textbook. Okay, I'm going to explain one example from the textbook. Look at your textbook. This one, page 15. Okay, page 15, you can look, we are going to do example B. Okay, we can do example B. Alright, so let me get straight into it. Okay, so let's look at the example on textbook page 15. Okay, area of segment of a circle. This one I'm doing is part B. Yeah? Okay, I want you to understand this part B, then we can go into the exercises. Okay, so we are supposed to use pi 3.142. We are supposed to find the area of this PRQ. Okay, find the area of this part. Now, if you look at the diagram, how can we find just this part only? What can we do? This comes back to like basic of shapes. This shape, okay, the first we have a sector shape, okay, and then if you realize we have a triangle shape. Okay, so we take the entire sector and we minus the triangle. Okay, so we take the area of sector, okay, the whole thing, take the area of the whole thing minus the area of triangle. Can we get this part only, the shaded part only? Will we get equals to that? Yes, definitely. Okay, so now let's do that step by step. So this is our first step, then this is our second step, then when you minus, you will get the answer. Okay, so let's do the first step. The first step, let's find the area of sector. Okay, so how to find area of sector? Still remember, 1 over 2 r square theta. Okay, do we have the radius? Yes. Do we have the theta? No, we don't have theta. So how to find? So looks like we got some extra work here. Okay, so I'm just doing like, you know, it's kind of like extra work. So part 1, okay, we have part A. We need to find the theta. So we need to find a theta means, in that case, we cannot, because we cannot apply without the theta. So we have to use triangle. Okay, use the triangle that's given. Look at the triangle. Okay, here the triangle is 4 cm. Here is 3.5. Here is 3.5. This is the one that we want to find, theta. So what we can do, first step, okay, divide the triangle into half. Divide into a 90-degree triangle, right angle triangle. So now just focus on this. Okay, so I'm drawing, oops, too much already. Let me just erase this. Okay, I don't want this. I just want a right angle triangle. So here, straight line, straight line, this is the theta. Here is 3.5 cm. So when you divided this part into half, okay, here will become 2 cm. Okay, can so following, we are just using the triangle, the basics of triangle. If you remember Okay, so we are going to use so, cha, to. Alright, so now let's look at which one we are going to use. So this is the opposite, 2 is the opposite. Okay, and we have the hypotenuse. So opposite over hypotenuse is sine. Okay, so sine of theta equals to opposite or hypotenuse. So from here we can find our theta. So opposite is 2, hypotenuse is 3.5. So sine theta is 2 divide 3.5. We get 0.571. Okay, let's take up to 45714. Okay, so from here we find theta. So sine, okay, inverse sine of this, we will get 34.85 degree. Okay, remember sine, cos, tangent, your theta you'll always get in degree. Okay, so this part is 34.85 means how to find the whole, the other side also. So we times by 2, because we need both sides. Okay, so 34.85. Okay, so I find the entire theta 34.85 plus 34.85. So now we already got our theta. Oh, we can times by 2. Okay, so 69.7 degree. So theta is 69.7 degrees. So let's just put that first aside. Okay, so we already found the theta. Now can we put in to find the area of sector? I think now we can apply. Okay, so now I find the area of sector. Alright, let me put it here. Area of sector is going to be 1 over 2 r square theta. Theta is in degree. I don't want in degree, so I need to change it to radian. So times pi over 180. Okay, so let's the pi substitute as 3.142. Okay, so 1 over 2 times 3.5 square times 69.7 times 3.142 over 180. Okay, so area of sector, the first one I get 7.452 centimeter square. Okay, so the whole thing, the area of the sector, we get 7.452. Okay, so we got the decimal slightly different, most probably because here we choose this part we should have choose more decimals. Okay, so if you check in your textbook, the area of the sector that they give there is 7.454, which is okay as long your first 4 significant figures are almost correct, because our 7.45 is already there. Okay, now area of sector done, the first part done. Now find area of triangle. Okay, to find area of triangle, what formula are we going to use? Because this goes back to your form 4. You need to like refer back to your form 4. Your triangle, okay, got 2 ways. One, you can use 1 over 2 times the base times the height. Okay, but then you need to find the height. Alright, you need to find the height, or you can use the area of triangle formula from form 4. Okay, this is P, Q, this is O. So we have here 3.5, we have 3.5, and here we have 4 cm. Okay, when you have all the sides, okay, this one you have to refer back to form 4, this one chapter 9. Okay, form 4 chapter 9. So area of triangle, if you have SSS is side, side, side. See, side, side, side. If you have all the sides, you are going to use the formula. Okay, hold on. Let me just show you my form 4 notes. So actually this is my form 4 notes, which I do these notes handwritten. Okay, so all my notes are actually handwritten. So okay, so let's look here. The area of triangle, this is called the Heron's formula. So when do we use the Heron's formula? When you have all the 3 sides. Okay, all the 3 sides. So now we are going to apply this. Okay, look here, this is the area. So this one, this part of the area, the formula, memorize it, Heron's formula. Okay, because this one I think is not given in your, I think it's not given in your SPM trigo formula, it's not. So this one you have to know. Okay, let me check. No, it's not. Area of triangle, don't have. So what you do, first you have to know your S. What is S? Okay, let me show you this part. I'm putting this here so that we can refer. Put up here. Okay, so the S is, take all the length of all the sides. Okay, so let's find our S. S is take 3.5 plus 3.5 plus with 4 cm divide by 2. So find our S first. Okay, 3.5 plus 3.5 plus 4 divide by 2. So we get 5.5. Okay, so our S is 5.5 cm. Okay, now we can apply this inside this formula. So the area of triangle, okay, area of triangle will be, okay, follow this, okay, square root S. Okay, so what is S? S is 5.5. Okay, then S minus A. So 5.5 minus, so what is the A, B, C is? This is A. Okay, this is B. This is C. It can be anything. Okay, you can do it reverse also. A, B, C can, no problem, as long you identify the A, B, C. Okay, so we use the Heron's formula here. So 5.5 minus 3.5, then 5.5 minus 3.5 again, then okay, 5.5 minus 4.5. Alright, now we key in our calculator. Okay, so let's do the inside part before we do the square root. Okay, so 5.5 times 5.5 minus 3.5, then 5.5 minus 3.5, then 5.5 minus 4.5. So inside here will be square root of 22. So square root of 22 is 4.6. Hold on, let me check. Oh, sorry, it's not 4.5 here. This is minus 4. So I was checking the textbook wrong already. Okay, here it's not square root 22. So hold on, let me just go up back and change the 4. Okay, so square root of 33. Square root of 33. We get 5.745. 5.745. Okay, centimeter square. Alright, so we already got area of triangle. This one done. So the last part, the third part, to find the area of segment. So area of segment PQR, not POQ. PQR, take the whole sector, which is 7.452, minus the triangle. Triangle is 5.745. So let's minus 7.452 minus 5.745. I get 1.707. 1.707. I'm not following the textbook because this answer, okay, although it's the fourth value here is different, it's okay, because in exam they will look at up to 3 or 4 significant figures. Okay, so this answer 1.707 centimeter square is the final answer. So if you need to refer to this, okay, kindly go back to your Form 4 chapter 9. Okay, you need to master the area of triangle for, because there's also another way, which is using the area of triangle by taking 1/2 times base height, can, no problem, or 1/2 AB, this one. Okay, we can use this also, 1/2 AB sin C, can. Totally up to you. As a student, you should be able to relate to which one you want to use. You want to use Heron's or you want to use this. Okay, it's totally up to the student, because either way you will still get the same answer. Okay, so now I hope you guys understand the example. So let's go into the self exercise 1.6. Okay guys, so I hope you're ready with page 16. Okay, page 16, self-exercise. So let's get started. If you're already started, you're ready with the answer, you can write down the answer if this video, you're watching this video during the premiere session. Alright, so I'm going to start with A. Okay, for each of the following sectors, find the area of segment ACB. Oh, I forgot to write the C. So the C will definitely be here. Okay, so the C, this is the C. Okay, so ACB, that means we are going to take the entire sector. Okay, we're going to minus with the triangle. Okay, we take the area of the whole sector minus the area of the triangle. So when you do this, you will get the shaded area. That is the segment. Okay, now let's find area of sector. Okay, the first step, find area of sector, which is 1 over 2 r square theta. So do we have r? Do we have the radius? Yes. Do we have theta? Yes. So we can immediately find 1 over 2, 7 square, 1.5. Okay, so let's key in our calculator. 1 over 2 times 7 square times 1.5. We get 36.75 centimeter square. So this is the first area done. Okay, now let's find the area of triangle. So area of triangle, okay, we need to use which formula? So this is where your basic comes back, your form 4. This one have to refer to form 4. Look at the triangle. The triangle, here we have 7 cm, here we have 7 cm. In the middle we have 1.5 radian. So how to find this part here? Because if I can find that, then I can use, you can use Heron's formula if you can find this. But instead of that, okay, what formula can we use to find the area? So if you want to remember, look back to, okay, this one is my form 4 addmaths notes. Okay, I'm just going to show you the area of triangle again. So this part, okay, we're going to use this. Okay, to find the area, I'm going to use 1 over 2 times the two sides, okay, and an included angle. So this one we are going to use SSA. Okay, so I'm going to use SSA, not the opposite, okay. SSA, okay, side angle, side angle. Okay, I'm going to use this. So the formula is 1 over 2 times the side sine of the angle. Okay, so in this case here, now we want to find the length of AB. Okay, so since we want to use sine, we have to change our radian to degree. Okay, so let's do this. So it's going to be 1 over 2 times the side times sine of angle, change 1.5 times 180 over pi. So the pi, I'm going to use 3.142. Okay, so now let's find 1 over 2 times 7 times sine of 1.5 times 180 over 3.142. Okay, so I get 24.44 centimeter square. So since we already find the area of triangle, then let's find the area of segment. So area of segment ACB. Okay, ACB. So of course in exam, please write it down like this so that the examiner can see. Okay, where's the final answer? 36.75 minus 24.44 centimeter square. So that's minus 12.31 centimeter square. Okay, let me check, is the answer correct? 12.31, yes. So this is the final answer. Okay, now why don't you try B and let's see if you can get the answer. So try similar to this step. Okay, step by step you have to follow. So let's try B. Okay, I give you about 1 minute. Try it in your notebook. Let me just drink water. Okay, I hope you're trying. So while you're trying, I'm going to do here the step also. Take the whole sector, okay, the area of the entire sector minus the triangle. Okay, let's start with area of sector. So always write down the formula. That is one tip. Writing down the formula will help you memorize. Okay, so do we have the r? Do we have the theta? Yes, we have everything. We can find immediately. So theta is 2 over 3 pi. So the pi, I'm going to write 3.142. Okay, so now just key in everything. Oh, r square. So this is square. So I get 104.73. Did you get that as well? 104.73 centimeters square. Okay, now let's go move on to area of triangle. So are you going to use this SSA? Okay, SSA, side angle. So let's look at the side. The side is 10 cm. The side is 10 cm. The angle is 2 over 3 pi, which we can change it. Okay, we can change it. Okay, so let's apply. So 1 over 2 times the both sides, 10 times 10. And times with sine of 2 over 3 pi. Don't use 2 over 3 pi. Okay, 2 over 3 pi, change it to degree. You want to change to degree, you times 180 over pi. Okay, the pi is 3.142, but in this case I'm just going to cut this. So I'm just going to key in the whole thing. 1 over 2 times 10 times 10 times sine of 2 over 3 times 180. Actually it's there 60, 120, right? Okay, so I'll get 43.30 centimeter square. So since we already found both, now let's find the area of segment. Area of segment ACB. We take 104.73 centimeter square minus 43.30 centimeter square. So that's minus 104.73 minus 43.3. 73 minus 43.30. We get 61.43 centimeter square. So that's should be your final answer also. Did you get it? If yes, just say yes or give a thumbs up or an emoticon that you got it as well. Okay, moving on to C and D, which I think you guys can try. C and D, okay? You guys can try that as homework, so you can also refer to the answer. C's answer is 2.049 and D answer is 42.52. So for C, make sure you change the 58 degree because you have to change it to radian. And then for D, use the example that I taught you here, the one using the textbook page 15, this example. Okay, this is exactly the method that you are going to do for D. Okay, all the best. Let me know if you get it in the comment. So I'm going to move on to question 2. Still self exercise 1.6, but question 2. Okay, we're going to try question 2. Okay, so are you guys trying out question 2 already? So let's get started. Just want to choose some bright color. Okay, let me go with green. Okay, the diagram shows sector MON with center O, radius is 3, the minor arc length, so this information is important for us. Minor arc length is 5. Find MON, that means find theta in degrees. Oh, okay, so we need to find theta in degree means, so since we have the arc length, we use the arc length formula. Okay, so the arc length is 5, the radius is 3, and the theta we need to find. So our theta, since if you solve this way, you will get it in radian. So 5 divide 3, which is 1.67 rad. Okay, so now change this to degree. So 1.67, or you can take 1.667, okay? 1.667 will be better for significant figures. Times, I want to change to, you want to change to degree. So you change to degree means we have to times with pi over 180, right? Hold on. This one, it's 1.667 times. Why I keep forgetting? Sorry. This one is times 180 over pi. Sorry guys. See, it's like too much of formulas. Okay, times 180 over pi. So 1.667 times 180 over pi. So I'll get 94. They ask in degrees, right? So 95.49, or you can put 95.50 degree. If they ask in degrees and minutes, then you can give 95 degree 30 minutes, because this is more than, okay, so 95 degrees 30 minutes. So you can give these two answers. All right, now let's go to B. Find the area of the shaded region. So first of all, find the area of the sector, then minus the area of triangle. Okay, so take can we find the area of sector first? Use the formula. Okay, quickly use the formula. Area of sector. Okay, let's find area of sector. 1 over 2 r square theta. So 1 over 2, r is 3 square, theta is 1.667. Use the radian, huh? Okay, so 1 over 2 times 3 square times 1.667. So I get 7.502 centimeter square. Okay, now let's find area of triangle. Area of triangle. So which formula are we going to use? Let me draw the triangle. So here we have 3 cm, here we have 3 cm, here we have the degree, 95 degree 30 minutes. So we can use the area of triangle that we learned in form 4. So 1 over 2 times with both the length, 3 times 3, and sine of 95 degrees 30 minutes. Okay, remember sine, cos, tangent must use degree. So 1 over 2 times 3 times 3 times sine of 95 degree 30 minutes. So I get 4.479 centimeter square. So overall area of shaded, so we minus. Okay, so always take your time to write down, okay, because this is how you practice. So you can see how teachers doing everything. That's how I literally teach all of my students. So the answer is 3.023 centimeter square. Okay, done question 2. Let's move on to the last question, question 3. So I hope you guys start trying first before you watch the last part. Okay, let's look at the last part of page 16. Okay, the diagram shows sector HOK for circle. Center is O, radius is 4. The length of chord HK, that means this part of the length is same as the length of the radius. That means all this is 4. Okay, 4 cm. Calculate HOK, that means calculate the theta. Alright, so how do we calculate the theta? What can we use to calculate the theta? Can we use S equals to R theta? Can we use 1 over 2 R square theta? Or what are we going to use? Because if you want to use RS, you need to know the arc length. Okay, so far we don't know that one, so cannot. Alright, can we use 1 over 2? Do we know the area? The area, do we know? No, so we can't use. So looks like we need to use, because we know the length here, okay, we know the length here. So what we can do is we can use 1 over 2, oh no, we can't use the area of the triangle. We use Heron's formula. Okay, we use Heron's formula. Okay, we shouldn't use Heron's formula as well, because If I want to use Heron's formula, what's going to happen is I need to know the area also. Okay, so Heron's formula, so nothing to do, anything we do with area we can't really use. Okay, so we can't use the 1 over 2 AB sine C, also cannot, because this is area. So the only most logical thing that we can do right now, okay, look at the triangle. Okay, the triangle has all same sides, isn't it? 4 cm, 4 cm, 4 cm. So if you have a triangle which has all the same length, so it's an equilateral triangle. So equilateral triangle has all same angles. So usually a triangle is 180 degrees. So we divide by 3. So one angle is 60 degrees. So obviously theta is 60 degree. So 60 degree we change to radian. Okay, so 60 times pi over 180. So change the pi to 3.142. Okay, or you can just say 60 times 3.142 over 180. So we get 1.047 radian. Okay, so the first part done, A. Next, B, area of shaded. Okay, this one we need to use area of shaded. So take the whole thing, area of sector minus area of triangle. Okay, so have you guys started? If yes, can you let me know what did you get for area of sector? So area of sector KOH is 1 over 2 r square theta. So 1 over 2 4 square 1.047. 2 times 4 square times 1.047. Okay, so I'll get 8.376 centimeter square. Then area of triangle. Area of triangle, you can use Heron's, you can use this. Okay, we use this one. So 1 over 2 times 4 times 4 times sine of 60. Okay, so whenever you use sine, remember to always sine 60. Always use this 1 over 2 times 4 times 4 times sine 60. Okay, so we get 6.928 centimeter square. So the final answer for area of shaded, okay, area of shaded segment is 8.376 minus 6.928. So you'll get the final answer, 6 minus 6.928. 1.209. Let's check. Oh, the answer is different. Hold on, let me check. The answer is 1.448. Did we do any mistake here? 1 over 2 times 4 times 4 times sine 60. So 8.376 minus 6.928. Oh, sorry, I minus. Okay, so this is why 1.448 centimeter square. Okay, alright, so this is why we need to always check back our answers, because things like this tend to happen. Okay, now I hope you guys benefit, okay, gain benefit from all these questions that we did. So do try the solving problems involving sector on page 18. So hopefully next time teacher will try to cover up that for self exercise 1.7. Of course, do more practices, okay? Do more KBAT question practices. So until I see you in the next video, bye.